Good morning, friends. We have been talking about T by W thrust loading and W by S wing loading. We have developed the background understanding. Today quickly we will summarize because it is important to understand there are many conflicting requirements. Let's say for wing loading, you will find wing loading requirements are different for different mission. Then how to choose which wing loading I should give weightage. So I thought today in 25-30 minutes we will just summarize. And let me write what we have done for wing loading takeoff. After having the understanding that when I am talking about wing loading, takeoff, in takeoff the most important thing is how fast I achieve the V liftoff or takeoff speed. That gets connected to V stall, and when I say how fast, it means acceleration. That again connects this to T by W. All these things we have seen. Then we also try to understand how to use statistical data based on some correlations, some model, data-driven model. And in that connection, we found W by S takeoff. Initially, for conceptual stage, I can use this formulation. For a propeller-driven, let's say IC engine backup, and then W by S takeoff. This is takeoff equal to takeoff parameter into sigma into CL takeoff T by W for jet-driven. You could easily see the connection of W by S and T by W. Similarly, we have discussed about W by S landing. And when I talk about W by S landing, we understand that when the airplane takes off, it has a full fuel. When it's coming for landing, the fuel will be consumed. Some percentage of fuel will be consumed depending upon what sort of mission it has got. So the weight will change, the wing area remains same. So W by S landing will be different. For many aircraft which are supposed to drop external stores, so W by S reduces primarily because the weight has reduced because we have ejected out or dropped some stores. For W by S landing, we approach it like this, that we followed, let's say, one regulation based on FAR 25, which roughly says, okay, you take 3455 VA square, and VA in this regulation has been taken as 1.3 times V stall. So VS during landing configuration, it is 2 W land, is landing by rho naught into sigma into CL max to S to the power half. Sigma is nothing but rho by rho naught. The density at the altitude where you are landing, and rho naught is sea level density. And using this, we have shown that W by S land is equal to 0.8563 rho naught sigma CL max into SLand. So it clearly tells you what is the density of air ratio at the altitude where you're going to land, what is the CL max value, and what is the length within which you want to make the aircraft stop, right? So this is W by S landing, this is W by S takeoff. And after that, we also have discussed about cruise, where we have seen W by S, cruise, or for cruise mission W by S is equal to Q infinity under root pi aspect ratio E CD naught. This is for range maximum, and of course we are writing for a propeller driven aircraft. So this is W by cruise when you want to maximize the range for a propeller driven airplane. And if I want to calculate W by S, I need to know what is the value of Q infinity. And please understand here, this expression was derived assuming CL is equal to under root CD naught by K, because we were maximizing range. For maximizing range for a propeller driven airplane, CL by CD is to be maximum, which tells me CL equal to CD naught by K. So if you are really flying with the CL, that means at that cruise lift should be equal to weight. That means half rho V squared SCL should be equal to weight. So V should be equal to 2 W by S by rho CL, and the CL is 2 W by S, of course. So CL is under root CD naught by K. The message is, once I am trying to fly at a CL, CD naught by K, then if you want to maintain lift equal to weight for a given S and given weight, then V is also fixed, right? And generally, you'll find the V will come a little lower, but the operator may require for a pre-specified V. Theoretically, you can have that pre-specified V by flying at different altitude, rho, but practical limitation is these altitudes are fixed by designers when they tell, please fly at this altitude where engine will be most efficient, or an air traffic controller will tell, this is the altitude is available for you. So this sort of a conflict or decision making point comes. Also think you are trying to conceptualizing a design and you want to know what is a W by S I should keep to maintain range, best range. At this stage, you have fairly good idea about what is aspect ratio you are looking for, maybe 7 to 8 or 9. You have already done a preliminary estimation. E, it is better to take E as 0.6 to 0.8 or 0.7. And typically CD naught, initially what should I take? For most of the existing airplane, you will find order is 0.02 in this 2.2, 2.3, 2.5, around this. But if you are looking into high performance civil airplane, maybe your Dreamliner, Boeing series, so they have attempted of this sort of a number, 6 to The important understanding is if you reduce CD naught, right, then the CL required for L by D max also goes down. See this expression for a given aspect ratio. Right? If CL requirement goes down, that means for the given aerofoil, you are flying at a lower angle of attack. If CL has reduced, that means you can fly at a different higher speeds but the same altitude, right? So that's the way you try to satisfy both the speed as well as the range requirement, right? So the whole design exercise goes on here, how to reduce CD naught. It's one of the advantages, right? Same time, you will see that if you go on reducing CD naught theoretically, the phugoid mode may get unnecessarily more excited. We'll just keep on your notebook, underline it. We'll come back when we will talking about stability and handling requirements designed for such airplanes. So message is, yes, if I ask you a question, if you are having this expression at a conceptual stage, whether you can get some value of W by S for a cruise, for range maximum, for a propeller-driven airplane, can I have some idea or not? The question comes, if I want to get W by S, I need to know what is the dynamic pressure, so I need to know the altitude and what speed I am going to fly, and then aspect ratio, these values you can take. It is generally preferred that you see your baseline aircraft or the mission requirement for which you are designing a conceptual aircraft, look for another aircraft which is closer to that and pick their speed, cruise speed, and try to iterate around that. Okay? And put that speed and see what is the CL required here, go back here and see for that CL what CD naught and K is required. All this iteration will go back and forth, right? Similarly for jet, W by S for cruise, this we have derived, and that comes to Q infinity into CD naught pi aspect ratio E by 3. Typically when you are talking about jet, you would expect the speed will be higher, right? And when I do this jet-driven aircraft, I'm looking for a cruise, best cruise, I know that here CL be equal to under root CD naught by 3K. You can cross-check from the earlier notes. So again, the story is same. You pick a CD naught based on the historical data. Again, it will be around 0.02, around that. Aspect ratio may be 6 or 7. E, I will always recommend you start between 0.6 and 0.7. And Q infinity is what altitude. Typically for a larger airplane, if it is a jet-driven engine, the engine recommender will recommend you fly in tropopause, where the temperature remains almost constant, the specific thrust-specific fuel consumption is most efficient. So if you have that altitude, then you know how to use this expression. Again, you have to take the help of some historical data to look for what sort of a velocity the operator is looking for, whether it is feasible or not, right? Another important thing comes when you are trying to look for loiter. But please understand, when we are designing a transport airplane, we give more weightage to the range rather than loiter. So indirectly I am telling you the wing loading will get more weightage during selection based on the range requirement, right? So for loiter we have seen for jet W by S equal to Q by aspect ratio E CD naught, and for the propeller W by S equal to Q infinity to 3 pi aspect ratio E CD naught. Same argument goes how to select Q infinity or CD naught, but if you are designing a transport airplane, you know that between W by S requirement for loiter and W by S requirement for cruise, I will definitely give more weightage to W by S requirement for cruise because that is the main purpose of the airplane. However, if I am designing some surveillance or reconnaissance aircraft, I may give W by S loiter more importance than the range requirement, right? So these things goes on changing based on what is the final aim. Another thing we talked about, instantaneous turn rate, where we have shown, we know that of course this psi dot is G by V under root n square minus 1, where n equal to QCL by W by S. So depending upon what sort of instantaneous turn rate you require, at what dynamic pressure, because V will be related to turn rate for a different load factor, all this gets clubbed because you understand N is L by W. Okay. So depending upon what is the N, at what speed you are looking for, you can have psi dot, and once you have N and dynamic pressure and CL, then you know what is the wing loading using this equation. To get CL, you know that L equal to NW. So from there you can find out CL. This is more important for fighter airplanes, mostly in a dogfight mode, fighter mode. And we have realized that during instantaneous turn rate, the drag will increase, so there is a possibility, Y possibility, instantaneous turn rate when you go maximum turn rate, but you lose the altitude, right? That may not be advantageous for your dogfight mode. So we talked about sustained turn rate. And there we showed that W by S for a sustained turn rate is Q infinity by N under root pi aspect ratio E CD naught. There is a word of caution that W by S for sustained turn rate may appear to be very, very low. But one good point we got, irrespective of whatever wing loading is required for sustained turn rate, T by W should satisfy this condition. This is important. And you can understand in takeoff, in climb, and in sustained turn rate, it is indeed T by W will play important role. So when I select T by W, I'll give this as a right segment based on which I should look for T by W. Why I am saying climb? You know that for climb, T minus W minus or T minus drag minus W sine gamma will be equal to 0 if it is going for a steady climb, and this is sine gamma plus 1 by roughly L by D. So T by W requirement is dictated by what is the flight path angle or climb angle you are planning to climb, and 1 by roughly L by D. So for meeting climb performance, I will give more weightage to T by W, right? And for this, I will give more to the W by S. I thought I must also add something on balance field length. You know what is the balance field length. The requirement is very simple. If I have a multi-engine airplane, let's say 2 engines are there, and it starts taking off from here, and let's say close by it, one engine fails. Then the answer is obvious. If at very early stage, if it fails, then I can apply brake because I have got sufficient length to hold the airplane. And let us say this is the V liftoff, and somewhere here it is failing. So now one engine is operative, one engine is not operative. Now the question is, if it fell very close to V liftoff, it is possible that I may not have sufficient length available to apply brake. Instead, I should ensure that even after one engine has failed, I should be able to do a prescribed rate of climb that may not be as high as rate of climb with the 2 engine, but fairly good enough rate of climb, and then go for a circuit and then again land back, right? So then the question is, what is that speed at which, if the engine fails, I should either apply brake or I continue takeoff with a lower rate of climb, go for a circuit and come back. The question is, what is that speed? So to address this question, the regulation wise, there is something called balance field length has been defined. So you see, I have written here, field length required for safety in the event of one engine failure at the worst possible time. What is the worst possible time? Worst possible time, if it is failing early, it is not a worst possible time. If near V liftoff it is failing, that is the worst possible time, right? So that is worst possible time in a multi-engine aircraft. So this balance field length or this philosophy is relevant for aircraft having more than one engine, right? In this discussion, we talked about decision speed, and let me write that these are very, very strict definition which is approved by the regulatory body. So I write decision speed, the speed at which the distance to stop after one engine failure exactly equals the distance to continue the takeoff on the remaining engine which is decision speed. So what is the decision speed? The speed at which the distance to stop after one engine failure exactly equal the distance to continue takeoff on the remaining engine, right? Okay. If I can identify what is the decision speed, then what I will do as a pilot, if the engine has failed below the decision speed, I will apply the brake. If it is more than the decision speed, I should be able to take off. Right? Clear? So based on that, this balance field length is defined as is the length required to take off and clear the specified obstacle when one engine fails exactly at decision speed. Right? Balance field length is the length required to take off and clear a specified obstacle, that is 50 feet or 35 feet, with one engine operative exactly at decision speed. So this is the balance field length definition. If you see my earlier lecture where we have given those parameter correlation given per propeller, airplane, and also have given how to get the balance field length from those chart, right? However, my advice always would be, because safety has a non-linear requirement, right? So it is better you take data from similar type of aircraft, twin engine aircraft, what sort of balance field length is prescribed in their manual, get more and more such data and take a decision at a conceptual stage. Thank you.